Alrighty, continuing on our journey of right triangles. Guys, remember what I mentioned at the beginning of our previous lesson. This chapter is super huge in terms of the future math that comes out of right triangles. So this is, again, very, very foundational for future math, especially trigonometry, is all based on right triangles. So really important that we're getting these concepts, so make sure that you're putting in the effort here to make sure that we understand these before moving forward. So what you're going to see in section 3 here is two types of special right triangles. And the reason they call these special right triangles is because they fit a certain pattern that we recognize that is used in all of trigonometry. And so what we're seeing in these two special patterns are certain ways that the legs relate to each other, and then how the legs relate to the hypotenuse. So what we're going to do on this first page is just focus in on one of those, and then we're going to work on the other type of special right triangle on the back side of this page. So the first one that we're going to focus on is the 45, 45, 90 right triangle. So what that means is obviously it's a right triangle because this is 90. And if you remember what we talked about in our last lesson, if this is 90, then these two acute angles always have to add up to 90 as well. Well, when these two guys are the same, in other words, when they're both 45, that creates a special pattern within the numbers of this triangle. So one of the things we learned in an earlier chapter was if these two angles are the same, then that makes these two sides the same, right? That makes it an isosceles triangle. It's what they called the isosceles triangle theorem way back in an earlier chapter. So anyway, as we look at these, as soon as I recognize that this is a 45, 45, 90 triangle, right off the bat, I need to know that these two legs are equal. So whatever this is, I know this is the same thing, right? So here's how they relate to the hypotenuse. In a 45, 45, 90 triangle, if you take one of the legs and multiply it by the square root of 2, then you get the hypotenuse. That's it. That's the pattern. So when I recognize this pattern again, I'm going to take the leg, multiply it by the square root of 2, and then I get the hypotenuse. What if we knew the hypotenuse, but not the leg? How do we go the other direction with it? Well, if I'm going to multiply by the square root of 2 to go from here to here, well, to go the other direction, I would then just divide by the square root of 2 to get this guy. So when they tell you the hypotenuse, then we can just divide it by the square root of 2 in order to get one of the legs. So that's what this, like the bullet is saying up here. So as you look at some of these, let's just go through those patterns and fill in these numbers real quick. So as I look at number 1, obviously this is a 45, 45, 90 triangle. So right off the bat, I'm going to say, well, if this leg is 8, then this leg has to be 8. Because those guys are always equal to each other, if it's a 45, 45, 90. So then how do we go from knowing this to getting this? Again, if I just take the leg and multiply it by the square root of 2, I get the hypotenuse. And that's it. That's all we have to do. So notice, kind of like what I said in the previous lesson about Pythagorean triples, knowing these patterns is really a shortcut. I could have done Pythagorean theorem to solve for x. I could have said 8 squared plus 8 squared equals x squared, and I could have solved that equation to get this answer. But again, it is so much faster and easier to just know the pattern of multiplying this by the square root of 2 to get this. Way quicker. So what if we're going to go the other direction? So what if I know the hypotenuse and I'm trying to figure out the leg? Well, again, I'm going to take the hypotenuse, and now if I'm going to go this way with it, I want to divide by the square root of 2 in order to get the leg. These guys nicely cancel for me on this problem, and obviously I'm left with just 3. So, and again, if that's 3, I know that this is 3. So I can fill all those in super quick by just understanding the pattern of the numbers here. Notice this now fits if I go the other way. If this leg is 3, well, yeah, if I multiply this by the square root of 2, I get 3 root 2 for the hypotenuse. So I know I'm good with my pattern, so we can just move on to the next one here. So you're welcome to pause and give any of these a try on your own ahead of me, but I'm going to go through all these examples so you can see plenty of examples. So on this one again, if that's 45, then this guy must also be 45, because these have to add to 180, right? So if this leg is 4, automatically I know that this leg is also 4. Well, how do we go from the leg to the hypotenuse? We simply multiply by the square root of 2, and that's it. Let's go the other way with it. So what if I know the hypotenuse and I'm trying to get the leg? So if I want to go the other direction, I am now dividing by the square root of 2. All right, so here's an issue, and this is what makes some of these a little tougher, is we got to be able to simplify radicals using some old algebra properties that you guys would have worked on in Algebra 1. So there was an issue that you ran into back in Algebra 1 that says you are not allowed to leave a radical on bottom of a fraction. And so you had to do something called rationalizing the denominator, which basically means I got to get rid of the radical. I need to rewrite this so that I don't have a radical on bottom of my fraction. So how do we do that? Well, we simply multiply top and bottom by that radical. Because essentially, all I'm really multiplying right now is 1, right? I mean, anything divided by itself is 1. And that's all I'm really doing, is technically I'm multiplying by 1. So I'm not changing the value of what I have. I am just rewriting it in a different format so that I don't keep my radical on bottom of a fraction. If I multiply straight across, on top I have 18 times the square root of 2, which is just 18 square root 2. On bottom, if I did the square root of 2 times the square root of 2, I would get the square root of 4. But what's the square root of 4? Just 2. So notice in that process, I got rid of the radical, right? That was the whole point, is I'm not supposed to leave radicals on bottom of a fraction. So I no longer have a radical down there. So the only other thing I want to look at is, can I simplify this any further? So if I look at the 18 and the 2, those guys are both integers. They can be reduced. Guys, remember, you're never allowed to mix a radical with a non-radical. These cannot reduce, because one's a radical and one's not. You can't mix those. But these can, because they're both non-radicals. So I can do 18 divided by 2 and get 9. So this is the way that we would want to write that answer. These are the hardest ones. They come with the most work, but it's really just 2 steps, right, is all I did to get this answer. And that's definitely something we'll be working on. So let me go to number 5. Give you one more practice round on this one. So if that made sense to you, if you want to give this one a try on your own, maybe you can pause right here and give this one a shot. I have 16 as my hypotenuse. I know to get to the leg, I have to divide my hypotenuse by the square root of 2. And this is where I run into that issue of, hey, I'm not supposed to leave a radical on bottom. So I multiply top and bottom by square root 2. So it looks like this. And all I'm going to do is multiply straight across. 16 times the square root of 2 is just 16 square root 2. Cannot combine those. On bottom, the square root of 2 times the square root of 2, as we already talked about, would just be the square root of 4. But what's the square root of 4? So, just as a side note, anytime you multiply a radical times itself, all that ever really happens is you drop the radical. So that's kind of the shortcut way of looking at it. If I did the square root of 5 times the square root of 5, I would just get 5. So anyway, one more thing I can do to reduce, because these are both even numbers, I can reduce them. It should just become 8 root 2. And that's the way we want to write that answer. Okay, 2 more. And we'll be done with part 1 here. All right, so we got a 45, 45, 90. Hypotenuse is 12. find the leg. So here's the same question, same type of question, but now they're just not giving you the drawing, right? And so they're describing it, but we're going to do it exactly like we just did the last one. If my hypotenuse is 12, well, what did we just do to go from the hypotenuse to the leg? We divide by the square root of 2, right? So I'm going to take my hypotenuse, divide by the square root of 2, and this is really my answer. This is the leg, but what we are running into is I'm not supposed to leave it like this. There's like a rule that says you're not supposed to leave a radical on bottom of a fraction. So we take these 2 extra steps here to simplify it, to rewrite it. So if I multiply by root 2 over root 2, again on top I would just now have 12 root 2. On bottom I would just have 2. And then if I can reduce, I want to reduce. So what you would find is, remember, these are the same value. This one is just reformatted so that I don't have a radical on bottom. But if you were to type in 6 root 2 into a calculator and get a decimal out of that, you'd get the same decimal if you typed in 12 divided by the square root of 2. Same value, right? They're just written in 2 different formats because this is the one that's kind of fits the rules that we're supposed to go with. All right, last one. Length of a hypotenuse. If the leg is 14, well, how do we go from the leg to the hypotenuse? Multiply by the square root of 2. So I'm going to multiply 14 by the square root of 2. That's it. That's all we had to do. All right, so that's the pattern of a 45, 45, 90. I'm going to show you one more. I'm going to introduce you to the other one, which is called a 30, 60, 90. So this is now going to be a 30, 60, 90 pattern. So again, keep in mind this is a right triangle. If this is 90, then these guys have to always add to 90, right? Because 90 plus 90 is 180. So then here's the pattern that we're going to get out of this. So this one's a little tougher because in a 30, 60, 90, the legs are no longer equal, right? I have a short leg, I have a long leg, and I have a hypotenuse. So with the short leg, first of all, recognize the short leg is always across from 30. Your long leg is always across from 60, and the hypotenuse is always across from 90. So that's super important. Everything in this pattern revolves around the short leg. Okay, so they put an X here for the short leg. That's like my base value. So how do we go from knowing the short leg to getting the hypotenuse? So as you can see right there, all I have to do is take this number and multiply it by 2, and I get the hypotenuse. It works the same way if you go the other direction. If I know the hypotenuse and I want to get the short leg, what would we do? Well, I would just then divide by 2. So when I want to go from short leg to hypotenuse, times 2. When I want to go from hypotenuse to short leg, divide by 2. All right, here's the other piece of this. How do we get the long leg? So how do we go from short leg to long leg? And the simple rule is you take the short leg. I don't know why they put an A here. But we're going to take the short leg and we're going to multiply it by the square root of 3. So whatever this number is, if I multiply it by the square root of 3, I get the long leg. So how do you think we go the other direction on this one? How do I go from knowing the long leg to figuring out the short leg? Well, if I had to multiply by the square root of 3 to go from here to here, then to go the other direction, I would divide by the square root of 3. So whatever this number is, if this is the number they give me, then I would divide it by the square root of 3 in order to get him. And that's it. Those are kind of our 2 patterns that we find within this. Okay, so I'm just going to go through as many examples as I can with you to help you out here. So follow along with this. All right, so I got my 30, 60, 90 pattern, and on this one, they're kind of starting us out with a tough number here. They're giving us 1/2. So it's not the easiest, obviously, when they start us out with a fraction, but that's okay. We can deal with it. All right, let's start with the easy one. If I want to go from the short leg to the hypotenuse, as we looked at up above, I simply have to take my short leg and multiply it by 2 in order to get the long leg. So if I take 1/2 and multiply it by 2, what do we get? We get 1. All right, so how do we go from the short leg to the long leg? Well, in this case, we multiply by the square root of 3. So if I took 1/2, and I'm just going to write this out so you can see it, and multiply it by root 3. Remember, when you multiply, you just go straight across. So on top, I get root 3. And on bottom, I get 2. So that would be my long leg. All right. Let's try another one. Easier number here. Again, they're giving me the short leg. If that's 60, this has to be 30. Right? So I know my short leg is always across from the 30. So how do we go from short leg to hypotenuse? All we got to do is multiply it by 2. So if I did 8 times 2, I get the hypotenuse. And how do we go from short leg to long leg? We simply multiply by the square root of 3. And there's my long leg. Not too bad, right? All right, let's try one where we go the other direction. What if I know the hypotenuse and I want to go the other direction and get to the short leg? Well, remember what the pattern was on this. From short to hypotenuse, it was times 2. So if I want to go the other way, I'm going to divide by 2. So if I did 11 divided by 2, I have the short leg. Guys, don't write these as decimals. Okay, we're gonna everything when we deal with right triangles, and you're especially special right triangles, you're always going to be asked to leave things as fractions and radicals, not decimals. Okay, so be in the habit of leaving things as fractions. If you could reduce this, I definitely would, but obviously I can't reduce 11 over 2. So we're going to leave it as 11 over 2. So now how do we go from short leg to long leg? So remember the pattern is, well, take your short leg and multiply it by the square root of 3. So I'm going to take my short leg, multiply it by the square root of 3. So it's just going to read 11 root 3 over 2. So there's my long leg, and here's my short leg. All right, let's keep going. The hardest ones are the ones where they start you with the long leg. Typically those are the hardest because now I have to divide by a radical, right? So here is our 30, 60, 90. So if I were to take my long leg, remember the pattern to go from long to short is to divide by the square root of 3. So what is 9 root 3 divided by the square root of 3? You can see that these would cancel, and I would be left with just 9. So there's our short leg is 9. How do we go from short to hypotenuse? We just multiply by 2. So there's my hypotenuse. All right, take a look at this guy. Here's something we ran into on the first page. If I want to go from long to short, I already know that I have to take my long leg, divide it by the square root of 3 in order to get my short leg. So this is the value of my short leg. But again, now I'm running into that rule where I can't leave a radical on bottom of a fraction. So how do we get rid of it? Well, we multiply the top and the bottom by that radical. So it looks like this. So on top, of course, that would just be 12 root 3. Kind of running into my other one here, but I'm going to do this. See if I can separate them. Tell you what, I'll just write it down here. So when I multiply the tops together, I get 12 root 3. When I multiply the bottoms together, remember what I said on the first page, what's any radical times itself? You just drop the radical. So it's going to be 3. But here's how it worked out. If I did the square root of 3 times the square root of 3, I would get the square root of 9. Well, what's the square root of 9? Just 3. So I now no longer have a radical on bottom. That was my goal. Can we simplify it any further? We can, right? Because 3 goes into 12. So if I reduce right here, it just becomes 4 root 3. Those are the hardest ones. All right, so here is our short leg. How do we go from short to hypotenuse? Remember, we just multiply by 2. So it becomes 8 root 3. All right, one last one. Welcome to give this one a try on your own. How do we go from hypotenuse to short leg? We know the rule is, remember, if I go from short to hypotenuse, it's times 2. So if I want to go the other direction, like right now, I have to divide by 2. So if I did 20 divided by 2, then here's my short leg. How do we go from short to long? We multiply by the square root of 3. All right, so there's our patterns. These are super important, so please watch this. Very, very popular question that you guys are going to run into is an equilateral triangle. So let's establish something here. We dealt with equilateral triangles earlier this year, which means all my sides are equal. Looks like this. So in an equilateral triangle, one of the things that we learned was all of the angles are 60 degrees, right? In an equilateral triangle. When I draw in the altitude, so when I draw on the line from the top so that it is perpendicular to the base, a couple things happen here. It splits that 60 in half. So we get this look right here. So when I draw in this altitude, it splits my 60 in half. So these both become 30, right? These guys are still 60. So now you're seeing I have 30, 60, 90 triangles on both sides, right? And the other thing that happened was when you drew in the altitude on this, it cut your base in half. So this is equal to this, right? So a couple really special properties that we got here. So let's see what they're telling us. The altitude is 36. So what I'm going to do is I want to focus on just this triangle right here. I'm going to redraw it so you can see this nice and clear. So what they're telling me is that my altitude is 36. That's him. They want us to figure out the length of the sides of the triangle. So what's him, or what is him, or what is him? They're all the same, so I just have to figure out one side of the triangle. Right? So I'm right back in what we were just doing up above. How do I go from long leg to short leg? We know we divide by the square root of 3. So if I took 36 and divided by the square root of 3, it's going to look like this. Let's clean that up a little bit. Can't leave that radical down there. So I'm going to multiply by root 3 over root 3 and get this. I'm going to reduce right here so that it becomes 12 root 3. So that's 12 root 3. How do we go from short leg to hypotenuse? We know the rule is to multiply by 2. So if I did 12 root 3 times 2, simply becomes 24 root 3. So, and because all three sides of this are equal, I know they are all 24 root 3. So he's 24 root 3, he's 24 root 3, and this entire length down here is 24 root 3. Right? So that's what they were looking for on this one. Let's try one more. And again, you can welcome to pause and try this on your own. But these are super popular questions. I'm glad we're going through them. So we definitely want to recognize on these guys that whenever I see that I have an equilateral triangle, because of what we just talked about right here, I always want to get this picture in my head. Here's my altitude. I know that created a 30, 60, 90 triangle. So if my side lengths are 12, so 12, 12, 12, how do you go from hypotenuse to short leg? We divide by 2. And remember, the other way I could have seen that was, remember we said right here, when I draw on the altitude, it cuts my base in half. So if I were to cut the side length in half, that's another way that I could have figured out that this is 6. How do we go from short leg to long leg, which is our altitude? We multiply by square root of 3. And that's it. So this one was asking for the altitude. All right. So that is it for this section.